Today, I want to talk to you about a very weighty subject. The subject is gravity. We've all been very carefully trained and honed by a lot of people we like to think that gravity is something that takes like two planets, which we can think of these as two planets. Think that gravity is something that pulls them together like that. But I'll tell you, the formulas that do that also can be read so that they're pushing together. So gravity can be pushing, not pulling. So gravity is something that can happen at your head, not at your feet. That is, it's pushing you down to the earth. Why was it ever thought of that gravity was a pulling force like that? Well, Sir Isaac Newton put that assumption into the formula he created. But the formula works by pushing as well. But that assumption has been carried forth by physicists for a long, long time and has been circulated in all the teachings that most of us have had. Why am I saying this? Why am I saying it's different than what we've all learned? Well, there's several reasons for that. First of all, one thing I've done is to spend about 6 years trying to find out which scientists came up with the idea that gravity was something that was a pulling force. There has been no such evidence any place in history that I can find. And that includes every physicist that's ever lived. Now, one thing about what happened with Sir Isaac Newton is that he had a friend, an older friend, named Maxwell. Well, Maxwell was working on magnets, and certainly magnets seem to pull or have a pulling force associated with them. And he trusted Maxwell, and Maxwell convinced him that that's probably the way gravity works as well. He had another friend as well, and his name was Johann Kepler. And Johann Kepler wanted Isaac Newton to say that it's a pushing force. Well, Newton didn't pay attention to him and went on to ascribe a pulling force to his formula. And that then has carried forward to today. But I'm going to give you some examples of why that doesn't work. That is, it works really well. For most part, we got people to the moon. We've got all kinds of satellites out there. It works for shooting a gun. It works for building elevators. It does everything we ever think that gravity should be measured. Well, let's look at this a little closer. I'm going to give you 3 different examples. First of all, this one is kind of a mind example. But let's say, just for talking, you could go and stand in the middle of the earth. Would you explode at that point because of gravity, or would you implode? Well, if you look at the Newton formula, he says that gravity is pulling from you on all where all the mass is, and the mass is all around you, so you'd be pulled apart at the middle of the earth if you went by Sir Newton's formula. But I've talked to other physicists, and they say, no, that's crazy. We know what it's like. You go to the bottom of the sea and you're pushed on from all directions. And the same is true in the middle of the earth. You'd be pushed on from all directions. So that means that gravity is a pushing force, right? All right, let's take another example. If this is the earth, where are the high tides? Here's the moon. High tides are on the moon side. They're also on the opposite side. Now, how can they be on the opposite side if the moon is pulling all the water to one side? They can't be. That physicists have a hard time talking about why that happens. But if gravity is a pushing force, there would be sort of a shadow between the thing that's causing gravity, which is coming in from the ends, from this side and from this side. There's so in between and at the outsides would be less pressure, and the pressure for gravity would actually be coming from both sides of the Earth more than from the ends, and therefore you'd have high tides. All right, that's another example. Let's try one more. Recently, two men, Saul Perlmutter and Brian Schmidt, both came up with the idea that the universe is expanding rate. They proved that sufficiently to win Nobel Prizes, and that is now what the universe is like, and it's expanding rate. Well, that's given all physicists a big problem who think that gravity is a pulling force, because now they got all this pushing going on around the outside of our galaxy, and inside where we live, you have gravity pulling. So now they've got to balance the pushing with the pulling, and they've had to create an awful lot of dark matter and dark energy to try and balance that equation out to their liking. I think this is wrong. It is all a pushing force. It's pushing out there, it's pushing in here. So take what I've said for what it's worth. You can make up your own mind, and I want to thank you for listening to me today. Bye.